historically good days.
Example 1. Find the slope of the line passing through the points whose coordinates are given. Slope between 2 points. And it was brought to my attention by my 5th period that there is a problem involving fractions. Let me just give you a real quick if a fraction problem happens. If you apply the slope formula, let's say that's what you have, top, bottom, multiply everything by 12, and then you got a regular problem. Okay, so create the fraction structure, multiply by the least common denominator every single piece, and then you get a non-fraction problem, and everything works out like it should. The other option would be to add or subtract the fractions and then reciprocate and multiply, but I'll just do the get rid of the fractions technique myself. With that in mind, finding slope of a line passing through points whose coordinates are given, the slope formula is, was, and always will be y2 minus y1 over x2 minus x1. Y has always been on top, X has always been on bottom. They have never ever been anything but that except for on certain students' papers that do it wrong. Okay, Y is on top, X is on bottom. And the requirement, the subscripts mean the second point Y minus the first point Y over the second point X minus the first point X. It could also be the other way around, Y1 minus Y2, as long as X1 minus X2 is on the bottom. It doesn't matter about order, as long as the order is the same. So if I call this here 1, 2, let's call that point 1, and we'll call this other point 3, 6.2. Y sub 2 is 6, Y sub 1 is 2. So the slope formula applying it is going to be 6 minus 2 over, let me put a minus in blue here. All right, and then over 3 minus 1. Color. Red 3 minus 1 purple. There we go. Okay. So the second Y, the second X, the first Y, the first X. The minus sign is part of the formula, so we just put it in there. And then what we're looking at is either addition or subtraction based on signs. Again, the formula says minus. These signs tell you whether you should add or subtract. 6 and 2 are opposite signs, we subtract. 3 and 1 are opposite signs, we subtract. In both cases, the bigger number is positive, so they're both positive results. 4 divided by 2 is 2. So the slope of the line passing through 1, 2, and 3, 6 is 2. If it comes out as a whole number, go ahead and leave it as a whole number. Over 1 is not required. It doesn't have to look like a fraction of the slope. Part B, same idea, same formulas. We've got 2 points. If I apply the slope formula here, it's going to be, I'm going to call this point 2 again and call this point 1 again. So y2 minus y1. So negative 2 minus 4. x2 minus x1. That's 1 minus negative 3. Again, the formula says subtract, so I put minuses when I apply the formula. Then the signs create whatever we're supposed to do. Minus minus means plus. Minus 2 minus 4, they're both the same sign, so I add 4 is bigger, so it's negative. 1 and 3, both positive, so I add 3 is bigger, so it's positive. In this case, negative 6/4 is a fraction. It does reduce to negative 3/2. That'd be a better answer. I can't make it any prettier than that, though. Improper fractions are much preferred to mixed numbers. For the purposes of slope, we're usually using it to graph a line. Down 3, right 2 is what that slope tells me to do. If I'm plotting points on the line with those 2 points on it, go down 3 and right 2, I get to another point. Okay, one extra thing I wanted to add about slope in here, you might want to put it somewhere in the blank space, if you still got blank space, I hope. 2 special slopes that happen occasionally. Slope number 1 is any number divided by 0. So if you do, you change your y on top and you get, like, say 7, change an x on the bottom, you get 0, 7 over 0, all right? Or negative 2 over 0, or 15 over 0, just any number over 0. This is a vertical line, has no slope. Division by 0 is undefined, so there's officially no slope to a vertical line. What would create a problem like that? Look, the points might be 3, 4, and 3, 6. All right? So if I do y minus y, that's 6 minus 4 on top, on the bottom 3 minus 3. The x's are the same number, right? The points, therefore, are vertically aligned to one another. We get 2 over 0, we get this vertical line position. So if I were to plot those be a vertical line. The equation of the line passing through those 2 points would be x equals what?
No.
There's a right answer to it.
What did you
X
write?
equals 3.
X equals 3, very good. Vertical line equation is always x equals number. The number x is in these points is 3, so that's the equation of the line. So if it's a problem where it says find the equation of the line that passes through these 2 points, once you see it's a no slope situation, it's just x equals whatever the x coordinate is. All right, the other possibility is 0 over any number. So the top number is 0, the bottom number is 5 or 17 or 12 or whatever. This is going to be a horizontal line. This has a slope of 0, because if you take 0 and divide it by a number, you still get 0, right? Okay, slope of 0 is a horizontal line. Points that would create a slope of 0 would be like 4, 2, and 6, 2. If I do y minus y on top, I get 2 minus 2. On the bottom, I get 6 minus 4. 2 minus 2 is 0. 6 minus 4 is 2. 0 over 2 is equal to 0. Once I see a slope of 0, I know immediately if I was trying to find the equation of the line, y equals what? 2. The y's are equal, you get y equals 2. X's are equal, x equals 3. Okay, if you recognize that immediately, hey look, the x's are the same, x equals 3. Hey look, the y's are the same, y equals 2. Again, if all they're asking for is slope though, no slope on a vertical line, 0 slope on a horizontal line.